tutorial channel. You are still on to Best Science Brain YouTube tutorial channel. If you are not subscribed to the channel, or if you are seeing the channel for the very first time, please move up to the channel's name, Best Science Brain. Under the channel's name, you see the subscription button. Tap on that button or the bell only once and get subscribed to the channel. Once you subscribe to the channel, you'll be seeing our videos always whenever we post our video online to get to you. Today, the best channel you can ever have for chemistry, physics, for mathematics, tutorials, and solution to examination questions. Today, we're going to look at another topic in organic chemistry. We're going to look at some hydrocarbon moieties. We're going to first of all treat the Alkyl group, which is a hydrocarbon moiety. So, the Alkyl group, by definition, is a hydrocarbon moiety. The word moiety means a part of organic compound obtained when an alkane loses one hydrogen atom. So we represent the Alkyl group with a general symbol R. So say that it's a hydrocarbon moiety or fragment obtained when an alkane loses one hydrogen atom. So we know in chemistry that alkanes have the general formula of CN H2N plus 2. Alkanes have earlier on been treated on this channel. Then with N starting from 1. Now for the Alkyl group, what will be the general formula? We now have CN H2N plus 2, the formula of the alkane, minus 1. Since that form went by alkane losing one hydrogen atom, we're now going to have CN H2N plus 1. But 2 minus 1 gives us 1. And also start with carbon number 1, just like the alkane. So you should know that the Alkyl groups is just like a radical group. It's not a group, it's not a full compound, and they cannot stand on their own. They form a part of organic compound. And actually that means the physical property of organic compounds. So having done that, if I wish to get the first member of the Alkyl group from this formula, I replace N with 1. I'm going to have C1 H2 times 1 plus 1. I'll have CH3. Then second member of the family, I'll replace N here with 2. That becomes C2 H2 times 2 plus 1. That gives me C2 H5. The third member of this family, I have C2, 3 in this case, H2 times 3 plus 1. And that gives me C3H7. By so doing, I generate all the Alkyl members. So you can see, Alkyl groups is a hydrocarbon moiety obtained when an alkane loses one hydrogen atom. Generally, we present the Alkyl group the symbol capital R, represent a radical group. Then, say that there are from alkanes. Alkanes have the general formula of CN H2N plus 2. Then subtract 1 from that formula, CN H2N plus 2 minus 1. We now have CN H2N plus 1 with the formula of the Alkyl radical or group. With N starting from 1, replace N with 1, get the first member CH3. Replace N with 2, the second member C2H5. Replace N with 3, you get the third member C3H7. Okay? Having done that, since we already know the first member, or a short way of doing this, so to know the alkanes, we can write alkanes on this side, can write the alkyl group on this side. So R on this side. So the first alkane is called methane. The first alkyl group is CH3. Removing one hydrogen from methane is now called methyl, replacing ANE with YL. The second alkane is C2H6, called ethane. Removing one hydrogen, I have C2H5, called ethyl, removing one hydrogen here. In the naming, replacing ANE with YL. Then the next alkane is called C3H7. C3H8, propane. Then you have C3H7, propyl. Got the name? C4H10, butane. C4H9, butyl. C5H12, pentane. C5H11, taking one away, pentyl. C6H14, hexane. C6H13, hexyl, and so on. So to get the alkyl group is not a problem. If you know the alkane family, just be taking away one hydrogen from each alkane, and so on. You'll be getting the alkyl members. Or you can get the alkyl members by using the general formula CnH2n+1, where N stands for 1. For the first member, we use substitution method. 1 here, you get that. Using 2 here, you get that. Putting 3 in place of N, you get this. Putting 4 in place of N, you get this. Putting 5 in place of N, you get this, and so on. Or, if you know the first member of the alkyl group, be adding CH2 to each member, you'll be getting the next member, because they stand as a homologous series. 1 carbon plus 1 gives you 2, 3 plus 2 giving you 5, 2 plus 1 gives you 3, 5 plus 2 gives us 7, 3 plus 1 gives us 4, 7 plus 2 gives us 9, 4 plus 1 gives us 5, 9 plus 2 gives us. So you can get the alkyl group either by from the alkane, taking away one hydrogen, from the general formula substitution method, or by adding CH2 to each homolog, you derive the alkyl members. So the alkyl group does not stand as a unique compound. It forms part of an organic compound. For instance, let's look at this compound. This compound is an alkanol called ethanol. You look at this compound very well, you can see when we write the condensed form, we'll have CH3, the first carbon taking 3 hydrogen, then the second carbon taking 2 hydrogen, and then OH. So we identify an alkyl group here. If we join this and that, these two, the methyl group and the methylene group, 1 plus 2 carbon, 1 carbon plus 1 carbon again gives you 2, 3 plus gives you 5. So this is an alkyl group called ethyl group, and then OH. So this compound is called ethanol, and formerly it was called ethyl alcohol because of the ethyl group. So the alkyl group here is the ethyl group C2H5. So the alkyl group does not stand as a unique compound of its own. It's part of an organic compound. Another example is this one. Wow, this is the haloalkane or alkyl halide. If you look at this compound, I have an alkyl group. That is from here. Remove the carbon, hydrocarbon moiety here is CH3 and then Cl. So this CH3 is an alkyl group called methyl, which is part of a compound. It can't stand on its own. This cannot be Carbon is not tetravalent here, so it's not unique here, so we have to put another atom here. So this is methyl chloride or chloromethane, because the CH3 here is the alkyl group in the compound. So alkyl groups cannot stand on their own as a unique compound. They form a fragment or part of organic compound. Another example is when we look at this compound, CH. This is the organic compound, an acid. You can see that. So the alkyl group here is this. This is the hydrocarbon part. So CH3, COOH. So this is the alkyl group, that is the methyl group. So this compound is ethanoic acid or acetic acid. Another hydrocarbon moiety called phenyl group. The first we treated was alkyl group. Phenyl group presented using capital P, small h, or phi. So this symbol stands for phenyl group. So phenyl group is a hydrocarbon moiety or fragment obtained when benzene loses one hydrogen atom. So when we abstract one atom from benzene ring, we have a phenyl group. So benzene is presented using the molecular formula C6H6. So remove one hydrogen atom from it, you have C6H5. So the phenyl group is nothing but C6H5. That is the phenyl group. Or if you go by structure of benzene, the skeletal formula of benzene is this, more like a hexagon with alternating single and double bond in each conjugated system, the benzene. So you remove one hydrogen from any point, be the alto, para, alto, meta, or para position. We have a phenyl group. So that would be, this is benzene. Then, so let's think of hydrogen from the alto position. So that is, this represents the phenyl group. We set it as C6H5. So that is the phenyl group. A group derived from benzene when benzene loses one hydrogen atom. So we should then have to differentiate phenyl group from benzyl group. If you have the benzene ring, we have a side chain joined to a methylene group. That is this. This is called benzyl group. So note the difference between phenyl and benzyl. So benzyl group is formed from a compound called, let's say, toluene. When toluene loses one hydrogen, if you have CH3 here, this is methylbenzene or toluene. Taking away one hydrogen, this is called benzyl group. So the phenyl group obtained when benzene loses one hydrogen atom, which is presented by using pH or phi symbol. Then that's the phenyl group, or that is structure. Then the benzyl group that has the benzyl group, that the benzene ring joined to methylene group there. So that's the benzyl group. Hydrocarbon moiety, we're done the alkyl group, we're done the phenyl group, we're now looking at the Aryl group. Got the word A-R-O-Y-L derived from aromatic group. So you can say this is a hydrocarbon moiety or fragment obtained by removing or abstracting one hydrogen atom from an aromatic compound. Now, the first aryl group is the phenyl group, which is obtained from benzene, as we described earlier on. When benzene loses one hydrogen atom, we have the phenyl group. So, since benzene is the principal aromatic compound, so phenyl group is a class under the aryl groups. Then we can see how what we call from toluene group is also under aryl group. Toluene is obtained when one hydroatom in benzene is substituted by a methyl group. This is toluene. That is toluene. So the toluene group will be obtained by removing hydrogen, not from the methyl group, but from the aromatic ring, either from any of this position. When I have this as a toluene group, the methyl remain intact when I remove hydrogen from any of the from the aromatic skeleton. So this is the toluene group, or can be written as C6H5 CH3 C6H5. That's the toluene group. Remember that benzene is C6H6. So all benzene is C6H6. So now C6, this will C6. If I remove the methyl group here, I have complete benzene, which is C6H6. Then if I put CH3 here, this is not toluene. Toluene is C6H5. Why is that the C6H5? Because looking at this should have been C6H6. So the C6H5 means that I remove one hydrogen and replace it with CH3. That is it. So the toluene group should be, that the iron here should be C6H4 here, because I have detached another hydrogen. So C6H4 CH3 is the toluene group. Then another example is the one called naphthyl group. They derive from naphthalene. Naphthalene is also aromatic. Naphthalene consists of two benzene rings fused together. That's naphthalene. So this is the structure of naphthalene. And naphthalene had the formula C10H8. So that's naphthalene. Now, to get the naphthyl group, what I'll do is remove one hydrogen here. I'll have C10H7. This is now called the naphthyl group, and so on. So let's go through our work again once more. We have the aryl group, meaning the aromatic group. A hydrocarbon moiety obtained by removing one hydroatom from an aromatic compound. The first or the foremost is the phenyl group, obtained by removing one hydroatom from benzene. We know that benzene is C6H6. One hydrogen atom, you have C6H5, called the phenyl group. Then we can see how from other aromatic compounds, like this from toluene group is from toluene. Toluene, otherwise known as toluene, is otherwise known as methylbenzene. That's toluene. Then that is toluene structure. Why this is it? So toluene is how the formula C6H5CH3, because why not C6H6? Because at this point, what had to be removed? Remaining 5. then CH3 coupled to it. Then to have the group, the aromatic toluene group, we have to remove one hydrogen, and that hydrogen will remove from the aromatic ring, while the methyl group remain intact. So let's say from this side, remove one hydrogen. That now give you CH3, C6H4, no longer C6H5 as before. Now we have the number 3 example, the naphthyl group obtained from naphthalene. Naphthalene consists of two benzene ring fused together. Now the formula C10H8, naphthalene. Naphthyl group, remove one hydrogen from it, you have C10H7, naphthyl group. So these are aromatic groups or aryl groups.